DFMA guideline for surface grinding. Design for ease of manufacturing. Simply geometry, uniform wall thickness, avoid the sharp corners. Ensure the flat and open surface for grinding access, the first one. The second one is avoid the small, thin or flexible component that are the hard clamps. Prefer the simple geometry, reducing the grinding setups. Design parts to be compatible with the magnetic chucks or mechanical clamps. Avoid the deep recesses or futures interface with the grinding head clearance. Next one is the material selection is a necessity and very important for the grinding manufacturing. The preferred mild steels, tool steels, annealed grey cast irons. Cautions: the aluminium harness steels tends to clock wheels require special abrasives. Avoid materials that generate excessive heat or wear on grinding wheels. Choose material that can retain the dimensional safety grindings. Next one is the design for assembly. Accessibility, fastening points, alignment feature and standard fastener. The position critical matting the surface to be accessible for the grinding before assembly. Fastening is very essential. Minimize the need for the post-assembly grindings. Incorporate the locations pin on futures to maintain the alignment during after grindings. Ensure the surface used for fit or sliding contact ground appropriate tolerance is essential. The standard fastener is very essential for holding the materials. The common fasteners simplify the procurements and maintenance. Next one is a design for precision surface finish. Realistic, the functional tolerance plus or minus 0.01 mm will needed. Use GD and T symbols for the flatness and parallelisms and perpendicularly. A special surface roughness value may be in 0.4 precision slide for the general faces. Design parts with the feature that facilitate the accurate machining, such may be in a flat, square, round, rectangular, any shapes we can and machining by using the differential chuck and fixers. Vibration damping is incorporated mass damping features to reducing the vibrations during the grinding. The vibrations reduce the enhancing surface quality. So we ensure the tight clampings and avoid the vibrations. Next one is the ease of maintenance and assembly. Design for access to wear parts. Examples are grinding wheel, belt, bearing for quick replacements. The designs ground surface to accommodate wear and regrinding. Allow the stock removal. Ensure accessibility of ground features during the maintenance. Include the reference flag or datum for the alignment and calibrations. Design component for a quick disassembly, reassembly without affecting the ground interface. Next one is safety and ergonomics. Operator safety is very essential. Operator should wear the product equipped dress and safety goggles using the gloves and ensure the wheel alignment and don't give the more depth of cuts based on the materials. Avoid the sharp corners and burns. Ensure the post grinding deburring is feasible. Design for safe handling, including the chamfer or lifting the point on large parts. Ensure the features are not located in the position that require unsafe operator process during the setup and inspection. Next one is the tolerance and fit. Tight tolerance for the critical parts. Ensure the critical component like slideways and spindles are manufacturing to tight tolerance and precision because it is a rolling parts allowance for wear the design components and with allowance for wear, ease of rework and replacements. Use ISO or ANC standard fits, examples H7 G6 for ground and soft bores. Apply the tight tolerance only for functional and critical areas. Allow the grinding stock typically 0.1 to 0.3 mm on machined surface. Ensure consistent tolerance on matting parts to avoid the cumulative error.